Hello everyone, welcome to our push-pull amplifier TV1 for ER229 at Brighton University. This is what we did with my friend here. Basically, this is the active filter part of the assignment where we've got the op-amp, and as you can see, this is second order because we've got two active components over there, which is our capacitor C3 and capacitor C5. Now we had to scale it. Instead of having 1 ohm resistors for R1 and R4, we used 10 kilo ohm for R1 and R4 respectively. Now since this one was half of this one, we therefore had 5 kilo ohm for R5. So we'll basically be sending in some input signal Vin of 50 millivolts, the maximum, and then we expect some output at our pin number 6 of our LM741 chip, which is our operational amplifier. Now looking through our circuit over here, you can see that we've got these resistors that we have set up here. I know it's a little bit messy, but yeah, bear with us. So this is the ground, as you can see there, and this is the positive rail, and this is the negative rail. This is where the input signal is coming from the signal generator. As you can see there, we're having a 200 Hz being sent through into our active filter circuit. So it is going to be filtered and it's going to go through an amplification of some sort through the amplifier. And in this case, we've got the amplification of -1, so it's unit gain amplification. So I'm going to do some tests. We have 200 Hz, as you can see. This is our input signal, and this is our output signal. As you can see, they're almost equivalent at the amplitude, making it proper. And as well, you can see that they are out of phase. They are anti-phase to each other. That is 180 out of phase, and that's one there. So at 200 Hz, we've got a clear signal with a unit gain as we expected, and indeed anti-phase as we expected. Now we're going to increase to 500 Hz. Yes, I forgot to point out that this is a low pass filter, so it is allowing low frequency components, and then as you see, and indeed the break frequency is 1 kilohertz. So as we can see right now, we're just below that. So as it is a low pass filter, it is going to allow those signals to pass through unattenuated. And then we are going to move on now to our break frequency. So this is 1 kilohertz, and you can see that the output signal is starting to be smaller than the input signal. So with our output signal there at less than 50 millivolts of what we did, it's actually 36 here. So it has dropped off, and you would imagine that to be there about our -3 dB point for our active filter. And we're just going to go above that just to see what is going to happen. So I'm going to send this to 2 kilohertz. And as you can see, at 2 kilohertz, we've got great attenuation of our output signal there, and that shows that it's working pretty well. And as we expected, our frequency, the break frequency is between 1000 to 2k hertz. Okay, then I'll just take this to a 5 kilohertz now, and as you can see, we barely have anything at all now. Output signal there. So yeah, it's pretty much working very well as expected, and